Welcome to SS2 Computer Science, Term 3, Week 2. In the previous lesson, we defined the 4 pillars of OOP. Today we go deeper into 2 of the most powerful, inheritance and polymorphism. These 2 concepts allow programmers to write flexible, reusable, and maintainable code, and they are at the heart of how large software systems are designed. By the end of this lesson, you will understand and implement single and multi-level inheritance, use the super function to access parent class methods, implement method overriding, demonstrate polymorphism with examples, and distinguish between overriding and overloading. Let us begin. What is inheritance? Inheritance is the mechanism by which a new class, child class / subclass / derived class, acquires the attributes and methods of an existing class, parent class / superclass / base class. Why inheritance? Code reuse. You write the common attributes and methods once in the parent class, all child classes automatically get them without rewriting. Extension. Child classes can add new attributes and methods specific to them. Hierarchy. Models real-world ISA relationships, a dog ISA animal, a savings account ISA bank account. Single inheritance. One child class inherits from one parent class. Example, animal dog, class animal, def__init__, self, name, sound self.name equals name, self.sound equals sound, def speak, self print, self.name, says, self.sound, def eat, self print, self.name is eating. Class dog, animal means dog inherits from animal, def__init__, self, name, sound, breed super, .__init__, name, sound, calls parent constructor to set name and sound, self.breed equals breed, adds a new attribute specific to dog, def fetch, self, adds a new method specific to dog, print, self.name, fetch the ball. Usage, D equals dog, bellow, woof, German shepherd, D.speak, inherited from animal, output bellow says woof, D.eat, I inherited from animal, D.fetch, dog's own method, print, D.breed, output German shepherd, dog's own attribute. The super function, super, refers to the parent class, super.__init__, name, sound, calls the parent __init__, method to initialize the inherited attributes. Without super, .__init__, the name and sound attributes would not be initialized. Types of inheritance. Single inheritance. One child inherits from one parent, simplest, dog inherits from animal. Multi-level inheritance. A chain of inheritance. German shepherd inherits from dog, dog inherits from animal, German shepherd ISA dog ISA animal, German shepherd has all attributes and methods of both dog and animal, plus its own. Example, class German shepherd, dog def__init__, self, name super, ._init__, name, woof, German shepherd, calls dog's constructor, def guard, self print, self.name, is guarding the house. GS equals German shepherd, Rex, gs.speak, inherited from animal via dog, gs.fetch, inherited from dog, gs.guard, a German shepherd's own method. Multiple inheritance. A child class inherits from more than one parent class. Python supports this. Example, class flying fish, fish, bird inherits from both fish and bird. This is powerful but can cause complexity. Diamond problem, handled in Python by MRO, method resolution order. Hierarchical inheritance. Multiple child classes inherit from the same parent, animal dog, animal cat, animal bird. Method overriding. A child class can redefine or override a method that it inherited from the parent class. The child's version takes precedence when called on an object of the child class. Example, animal has speak, that prints the generic sound. Class cat, animal def speak, self, overrides animal speak, print, f, itself.name, says meow. C equals cat, whiskers, meow, c.speak, calls cat speak, not animal speak, output whiskers says meow. This is method overriding, the most common way to customize inherited behavior. What is polymorphism? Polymorphism comes from Greek, poly equals many, morph equals form. In OOP, polymorphism means, the same method name can be used by objects of different classes, and each class provides its own implementation of that method. Polymorphism in action, class animal, def speak, self print. Class dog, animal def speak, self print, f, self.name, says, woof. Class cat, animal def speak, self print, f, self.name, says, meow. Class cow, animal def speak, self print, f, self.name, says, moo. Now consider this code, animals equals, for animal in animals, animal.speak. Python calls the right version of speak, for each object, Bello says, woof. Then Whisker says, meow. Then Daisy says, moo. Each object responds to the same speak, called differently. This is polymorphism. Key principle, the code that calls speak, does not need to know what specific type of animal it is, it just calls speak, and the object itself knows what to do. This is very powerful for writing flexible code that works with many different types. Duck typing in Python, if it walks like a duck and quacks like a duck, it must be a duck. Python does not check the type of an object before calling a method, it simply calls the method, and if the object has it, it works. This is a form of polymorphism. Method overloading versus method overriding. Method overriding, child class provides its own version of a method inherited from the parent. The method name is the same, the class is different. This is runtime polymorphism. Method overloading, same class has multiple methods with the same name but different parameter list. Python does not support traditional method overloading, unlike Java/C++, but it can be mimicked using default parameters or *args. A complete practical example combining inheritance and polymorphism, a school management system, class person, def__init__, self, name, age self.name equals name, self.age equals age, def greet, self print, f hello, I am self.name, age, self.age, dot. Class student, person def__init__, self, name, age, student_id, grade super, .__init__, name, age, self.student_id equals student_id, self.grade equals grade, def study, self print, f is self.name, is studying, def greet, self, overrides person's greet, print, f hello, I am, self.name, student id, self.student_id, grade, self.grade, dot. Class teacher, person def__init__, self, name, age, staff_id, subject super, ._init__, name, age, self.staff_id equals staff_id, self.subject equals subject, def teach, self print, f is self.name, is teaching, self.subject, def greet, self, overrides person's greet, print, f hello, I am, self.name, staff id, self.staff_id, I teach is self.subject, dot. Demonstrating polymorphism, people equals, for person in people, person.greet, calls the right version for each object. Advantage of polymorphism, the for loop code is simple, it does not need to check what type of person it is, each object handles its own greet appropriately. This makes code extensible, you can add new types, e.g. principal, without changing the loop. WAEC questions on inheritance and polymorphism. Define inheritance and polymorphism, distinguish child class from parent class, write class hierarchies in pseudocode or Python, explain method overriding, describe the purpose of super, trace code output for inherited and polymorphic method calls. Key points, inheritance, Child class acquires attributes and methods from parent class, models ISA relationships, promotes code reuse. Syntax in Python: class child class, parent class. Super calls parent class constructor or methods. Types: single, multi-level, multiple, hierarchical. Method overriding: child class redefines a method inherited from parent, child's version runs when called on child object. Polymorphism: many forms, same method name works differently on different class objects, achieved through method overriding. Doctyping: Python calls methods based on whether the object has the method, not what type it is. Method overloading: same class, different parameters, versus method overriding, child redefines parent method. Example hierarchy: person, student and teacher, both override greet, a loop calls greet on any person type polymorphically. Benefits of inheritance: code reuse, extensibility, logical hierarchy. Benefits of polymorphism: flexible code, write once, works with many types, easy to add new classes without changing existing code.